Review of section 1.1, lines in the plane, first day. Our objectives are students will be able to calculate the slope of the line graphically and algebraically. Second objective, students will be able to graph a linear function using slope-intercept form. A couple of slides of key concepts. Your formula for slope, so there's different formulas. This one we're looking at is the same as when you say change in y over change in x. This delta, Greek letter delta, represents in math change in. Another formula that you might be familiar with is y2 minus y1 over x2 minus x1. But really, that's change in y over change in x. Change is a difference. A third representation is rise over run. This one we use to find the slope graphically. This is the one that we use to find the slope algebraically. On this slide you'll find the algebraic form and what we call it, its description or its name. So we have standard, slope-intercept, point slope, what the algebraic form of a vertical line is, and what the algebraic form of a horizontal line is. So on this first slide, I've gone ahead and taken the time to do the calculations and graph. So we plotted the points, and by the way, let me get just a pen. This is going by 2 on the x-axis and 1 on the y-axis. So they're different scales. So I plotted these 2 points. -8, -1 is this point. -8, -1. And this point up here is -4, 2. And then I used the definition of rise over run. So I decided to start here, which means I have to rise 1, 2, 3 units and run 4. Remember, each box is 2 units. Rise over run, rise over run. So your slope is 3 over 4. Now if we had to use a formula or figure out the slope algebraically, this is where we use our difference in y over difference in x. y2 minus y1, x2 minus x1. Okay, so I've gone ahead and connected the y coordinates, connected the x coordinates. I've chosen a direction. Notice the arrows are going the same direction. You could have gone from -1 to 12 and -8 to -4. So have to be very consistent. And then we're going to put those numbers in for y2 minus y1. So 12 minus -1. So that's a difference in my y coordinates. x2 minus x1. A difference in my x coordinates. And then you simplify by using your arithmetic skills. So this becomes 12 plus 1 over -4 plus 8. So we have 13/4. And it's a good practice to leave it as an improper fraction. So our slope, finding the slope algebraically between these 2 points would be 13/4. The last one is if we're given an equation, -2x minus 3y plus 12 equals 0, and we're asked to graph it. Easy way to graph is putting it into slope-intercept form, which means we need to solve for the y. Okay, so starting with this equation, I want to isolate the y. So I'm going to take this -2x and we're going to move them to the other side, as well as this plus 12. And as we learned in pre-algebra, when you change sides, you change signs. So let me go ahead and write down that step. The -3y remains. Now we have a positive 2x and a -12. We're almost there. I want to isolate the y. So I'm going to divide through by -3. And then you get y equals negative 2/3. X, negative negative is a positive. 12 divided by 3 is 4. Second step, identify the slope and the y-intercept. So the slope we can clearly see is negative 2/3. So we're going to go down to the right 3 from our y-intercept, which is 4. And we're ready to graph. So when you're graphing, think of in slope-intercept, the m is the move number, and the b is the begin on the y-axis. That's your y-intercept. Alright, so let me go and draw an x-axis and a y-axis. Let's think over here will work. Oops. And I'm going to go right there. That's my x. That's my y. My scale will be 1s. You begin with the y-intercept. 2, 3, 4. Place a point. And now we move. We use the move number, the m number. Down 2 over 3. 1, 2, 1, 2, 3. And then you're going to connect the dots with the straight line, of course. And there's your line. You can replay this video, you can pause it as many times as you need, and if you're absent, hopefully that helps you get caught up.